So, I want to capture the total solar eclipse. So, on April 8th of 2024, a total solar eclipse will span America, or did by the time this video is out, and I want to capture it. But that's a little complicated, so let's talk first about why a solar eclipse occurs. A solar eclipse occurs when the moon passes between the sun and the earth and partially or fully blocks the light from reaching the earth. This happens because of a really cool coincidence where the sun appears the same size in the sky as the moon. The sun is 400 times in diameter, the size of the moon, but also 400 times further away from Earth. We can demonstrate this really easily using cutouts. So for the sake of this demonstration, you are the viewer on Earth, this is the sun, and this is the moon. I've made the sun twice as big instead of 400 for the sake of my sanity, and we're gonna hold the moon, which is half the size, half the distance away between the camera and the sun. So if I move the moon in between the camera and the sun, it should appear almost exactly the same size. And this is the same phenomena that occurs on Earth when we look at the sun and the moon. Now, before we go into it, there are 4 types of solar eclipses. The first one is a partial eclipse, and this occurs when the angle between the sun and the moon isn't quite perfect for the centers to pass over. So, from our line of sight, even though it may cross directly over it, it doesn't cross over the center, and it only partially covers it. The second one is an annular eclipse, and this occurs because the orbit of the moon isn't a circle, it's an ellipse, and sometimes it's further away from the Earth. So, if we hold our sun again next to my face, and instead of holding it halfway, I'll hold it a little bit closer to myself. Now when it passes over the sun, even the center of the sun, it doesn't cover it fully because it appears smaller in the sky. The third one is a hybrid eclipse, and that's going to be a combination of 2. So because of the location of the eclipse and the curvature of the Earth, in some places we'll see an annular eclipse, which we just described, and in others we'll see a total eclipse, the 4th and final type. So a total eclipse, like we demonstrated in the beginning, occurs when the conditions are just right, that the moon passes between the sun and the Earth such that it covers it fully. You might wonder, why isn't there an eclipse every month? The moon orbits the Earth once a month, which means it must pass between the sun and the Earth once a month. But because that orbit is tilted, it's not always going to be directly in the line of sight. Sometimes it'll pass below and sometimes above, so that doesn't actually block the light from reaching the Earth. However, eclipses aren't really all that uncommon. A handful of eclipses occur every year, with a total eclipse occurring roughly every 18 months somewhere on the Earth. In the USA, the last total eclipse that spanned the country occurred in 2017, and now another one occurring in 2024. However, there won't be another eclipse expected until 2045. So, I mentioned that filming the eclipse is a little bit complicated. Let me explain why. There are 2 main unknowns that I need to figure out before the eclipse occurs. The first one is setting. How do I find myself where the eclipse is, when it is, in a place that I can see it, where there's no clouds blocking it? The good part is that I live in Northeast Ohio, so I'm already living somewhere where the path of totality occurs. The bad part is that I live in Northeast Ohio, so it's usually cloudy, especially this time of year. It's still too far out for me to know the forecast to see if it'll be sunny or not, but I need backup plans. The second unknown is actually filming the shot. Filming an eclipse is more difficult than what we're doing here. It requires specific equipment, camera settings, and timing, all of which I'm not really sure how to do yet. But we've still got a few weeks, so I'll bring you along with me as I figure it out. Okay, so my goal is to walk away from this video with a shot of the eclipse. So not just photos, but I want to have a full video, meaning I'm going to have to do a time lapse. But there's a couple other things I got to think about first, and that's going to be the equipment. So what I have is a solar filter. This is like when everyone's using those sunglasses to protect their eyes when they look at the sun during the eclipse. I got sunglasses for my lens. So we'll be using a solar filter, and we'll be testing that out today with the sun behind us. And then also using the highest focal length lens that I have. So we're looking at the Canon Zoom FD 35 to 105 millimeter. and this is going to be entirely manual, no auto settings that I can rely on, and that's going to be okay because for a shot like this with the Eclipse, I'm going to need to figure out those specific settings that I need anyways, and that's why we're here today. If I can get a video of the sun practicing with the filter and the lens, we can figure out what exactly settings I need to get it just right. But before that, we also need to figure out the time lapse. So I figured some of it out, but I'm going to show you guys my thoughts here first. So stand by. Okay, so let's work through that. I know the totality is going to last about 3 minutes and 49 seconds, and we want totality to last after everything's been edited and calculated to be about 3 seconds. Let's say we're shooting and our final video will be 30 frames per second, and we want it to be 3 seconds of totality. We're going to need 90 frames. So 90 frames shot over 3 minutes and 49 seconds. We can continue that math. We have 229 seconds that we have totality. That's just adjusted for that 3 minutes. And then we divide that by 90 frames. That means that I'm going to need 2.5 roughly seconds for each frame, meaning that I'm shooting a photo for the time lapse every 2.5 seconds. And that could be adjusted. I could do 2 and get more photos, or every 3 seconds and get fewer and it'll move faster. When filming the sun, this is what it looks like without any solar filter applied. It's overexposed, and over time it's going to damage the lens. So let's apply that solar filter, and we can see that immediately it pulls the exposure way down and makes it possible to see a ring where the sun is. Now, to test out the camera settings with a few photos, the first thing I started with is an ISO of 400 and a shutter speed of about 1/2. So I decreased the ISO to 100, which helped out a lot, and then increased my shutter speed until I liked what I had and had a defined circle for the sun. For my camera, that ended at about 1/30th of a second. Then I tested out the time lapse using the camera settings I liked in an interval of about 2 seconds. This 20-second time lapse is about 20 minutes real time, and I like the pace that the sun moves at. I don't want it going any faster, but I also need to keep in mind that it might move out of frame if I'm not careful during the eclipse. So, one of the best resources that I can use right now is from the National Weather Service, and it gives us a map that predicts how much of the sky is going to be covered by clouds at 3 p.m. during the time of totality for the eclipse. If we take a look at Northeast Ohio, we can see that it's not looking great. There's definitely cloud cover, and at some of the worst areas, up to about 70%, with it getting worse as we go to the Northeast and a little bit better and more clear as we go west. So we can take a look at our surface analysis chart and see what's happening as far as frontal systems and pressure systems. Any type of front will typically bring in overcast, low-lying clouds with precipitation, and here we have a warm front followed by a cold front and an occlusion to the north. So it's looking pretty bad, but at the same time it is dissipating. We see some frontalysis here where those fronts are breaking up, and instead of just having a really strong front pushing through, we might actually have that front dissipating as it comes through, allowing some of those clouds to disappear and skies to clear up. So this is the forecasted clouds at midnight tomorrow, and we can see that along the frontal boundary, it's carrying an overcast layer at about 6,000 to 8,000. And as we push forward in time, we can see that moving along with the fronts and slowly dissipating, bringing behind it clear skies and good weather for the eclipse. So as of right now, it looks like my best odds are to drive an hour to 2 hours to the west towards Toledo and potentially having better sky cover there. I haven't made up my mind, so I'll wake up early tomorrow morning, we'll get an update on the clouds, and if I've got to drive, I'll leave super early and I'll bring you guys with me. But fingers crossed that Northeast Ohio will be good. It's April 8th, 2024, and the weather looks great. I'm going to drive about an hour and a half to the west to get to an area with a good view of the eclipse and a little bit of better skies, but we shouldn't have a problem seeing it, so let's do this.
Is it gone?
Holy shit, Holly. That's crazy.
Oh my. Holy shit.
Oh my god.
Oh my god.
That is probably the most beautiful thing.